Hi, I'm Bryce, and welcome to Making Things. And I'm here with Will, and today he's going to build something awesome with us. What did you bring?
So we're gonna build one of these speakers. It is made of a bunch of cardboard and the top of a soda bottle, along with a bit of magnet wire as a voice coil. We are also gonna attach it to this simple amplifier board so that we can have a good signal that we can hear.
Cool. Let's try it out.
Yeah, if you just plug that in, it's on over here, and if you hit play, we should hear something. Yeah.
Nice. Cool. Let's get started.
So a speaker is just a system for taking an electrical signal and turning it into motion to push air to a vibration that pushes air back and forth. So what we're going to do, we're going to build an electromagnet using this coil of magnet wire, and we are going to mount it near a permanent magnet and connect it to an audio cable so that we can turn our magnet off and on using an audio signal. So let's get started. So you need the top of a plastic water bottle. Some batteries, a battery holder, a coil of magnet wire, 2 powerful neodymium magnets, a little piece of dowel, 2 alligator clips, 1 amplifier board with a lot of connections coming off of it, a audio cable, 1/8-inch audio cable, and along with some electrical tape, some double-sided tape, some sandpaper, and some cardboard. The first thing we're going to need to do is we're going to use the top of this water bottle as the voice coil, the thing we're going to wrap our magnet wire around to make our electromagnet. So I'm going to cut the top off, and then I will clean it up just as best I can, get a nice smooth 1/2-inch lip at the bottom here. Using the top of this plastic water bottle, it does a couple different things. It gives us this really nice lip that we can coil our magnet wire around, but it also means that we can experiment with different kinds of speaker cones by connecting them to the different lids and screwing them off and on and get a nice connection there. So I'm going to take the magnet wire. I am going to, as best I can, being careful not to get it tangled, coil this wire between the 2 lips of the water bottle here. We need to have both ends of the wire exposed so we can make connections to it, because this will be the electrical connections for our speaker. I'm going to coil it as tightly as I can and as cleanly. And what I'm doing here is making an electromagnet. Whenever electricity passes through a wire, it generates a magnetic field in a loop around that wire. If the wire is coiled, the magnetic fields generated at each part of the wire line up, so the resulting total magnetic field goes in the same direction out through the center of the coil. Each part of the wire makes the magnetic field in the center of the coil stronger, and by wrapping the wire in more coils, the field gets stronger with each additional coil. We're going to put this loop around the magnet, and so when the magnetic field is generated in one way, it will be pulled towards the magnet. In the other way, it will be pushed away from the magnet. And so we can make a vibration just by turning that magnetic field off and on. Once we have the coil around the bottle, I'm going to take a little piece of tape and just wrap it around to hold it in place. I'm being careful not to tape the lid onto the bottle because we want to be able to take the lid off and on to experiment with different kinds of speaker designs. And I'm just going to be careful. I need both of my wires to be sticking off the end of the coil so that I can make connections to both of them. Fold these over. This wire is called magnet wire, and it's called magnet wire because it's used for making electromagnets. It's incredibly thin, and it has this instead of having the thick plastic insulation that wire more commonly has, it has a very, very thin enamel coating. And that allows us to have more coils of wire closer together to make a stronger magnet. In order to take the insulation off, we use sandpaper. I'm going to pinch it, but I'm not going to pinch it too hard because if I pinch it too hard, this will just rip. I'm going to gently sand around the edges, and if you look closely, you can see that there is a slightly different color copper wire underneath the insulation. And you should be able to see that. So I can see the difference here, so that looks pretty good. The next thing we're going to do is we're going to build a little cardboard base for our speaker. And if you ordered a kit from us, we will have sent it in this USPS priority mailbox. So I'm just going to cut the middle rectangle out of this. And we'll use some of the other parts of the project later. And this is going to be a base that we can attach our amplifier and our speaker and everything to. So it's kind of all one unit. So what we're gonna do is we're gonna take this little wooden dowel, we're gonna stick it on here, and we're gonna put the magnets on top, and it's gonna be a post for this to sit around and vibrate up and down. So we're going to attach this with this double-sided tape. If you want to use hot glue for this, it would make a slightly more rigid connection if that's a tool you have available. But the double-sided tape seems to work pretty well. And one piece here. I'm going to stick the magnet on like that. So the next thing I'm going to do is I'm going to cut what's called the speaker cone. It's going to be the piece of material that moves up and down and vibrates. And for this, I'm just going to cut the simplest shape I can imagine. I'm just going to cut a medium-sized rectangle. There's a lot that you could experiment with. Different shapes, different materials will have different acoustic properties, and some will sound better with higher frequencies, some will sound better with lower frequencies. I think there's just a lot of really interesting experimentation, but I'm going to start out really simple with just this little square here. The water bottle lets us take the cap off and experiment with different kinds of cones. So I'm going to take this tape here, and I'm just going to stick the cardboard onto this cone with the tape. Just put this roughly in the center. Then I can just screw it back on to here, so it's nice and snug. This is a thing where if you wanted to use hot glue or some other kind of adhesive, for this part in particular, you would probably get a much more rigid connection, and you probably transfer the vibration a little bit better. But the tape does seem to work fine. So this kind of speaker cone here is gonna sit on this post, and when the electromagnet gets turned off and on, it's gonna kind of wiggle up and down. But we want to support the weight a little bit with a kind of simple spring here, just so it can move more freely. So we're going to make a very, very simple cardboard spring. I'm going to cut one of these pieces in half, and I'm going to just do a kind of simple accordion fold back and forth. And so I have something that is like that. I'm going to make two of them. So I've made these two cardboard springs here, and I'm going to attach them to the speaker cone using just a little bit of tape. Again, this is something that you can do a lot of experimentation with. The speaker will sound different when the coil is held at different heights. After you build it, you might want to take it apart and cut the springs or change them or make them bigger or shorter or make them out of something different. I'm gonna just do this, and I'm going to have the two springs kind of rotated 90 degrees to each other. And I think that will just prevent the cone from being able to move too much in any single direction. So I'm gonna take two pieces of tape and I'm gonna stick them to the bottom of these springs here. And then once they are on, I'm gonna position it so that the coil of wire sits around the magnet. And I'm just gonna tape everything down. And you'll probably get the optimal sound if the coil of wire is at about the same height as the magnets. So here I have the speaker, and the magnetic field will push it up and down. So now we have built a speaker. If we send any audio signal into these two little wire connections here, we will generate a magnetic field, and we will make a vibration that makes a sound. Most of the devices that we use to produce audio output, like the ones that are really common, like our phones and our computers, generally expect some kind of amplifier if we're gonna hear them well. So it will make sounds that are probably about as loud as your headphones, but it won't be right inside of your ear, so you won't be able to hear it very well. So we're gonna use an amplifier. We're gonna use an amplifier board to amplify our signal before we send it to our speaker. So this is the amplifier board that we're gonna work with. So there are 9 connections on this amplifier board. This red and black wire here are for the power and ground to power the board. On the same side as the power and ground, there are these 3 input connections, left, right, and ground. It's a stereo amplifier. On this side, there are 4 connections for the stereo output. So these will go to your speaker, and it's power and ground for left and right speakers. What an amplifier does is it takes a signal that is low power, it takes a power source, the battery is in this battery holder, and it adds its power source to the signal that it gets, so it produces a higher power version of the same signal. So we're going to attach this battery pack to the board. So the battery pack has a red wire, and it's going to go to the red wire on the plus wire on the board, and the black wire is the ground for the battery pack, and it goes to the minus connection on the board. And then I'm going to put my batteries into the battery holder, but I'm going to leave it off so that we don't have any short circuits or anything while we work. And then this is going to be this audio cable can attach to a computer or a phone or anything else. It's called a TRRS cable. The cable has 4 connections. There's the red, which is for the left speaker output. The green is the shared ground, and the white is the right speaker. The black is for the microphone, which we won't be using. So we're going to attach the middle green cable to the green cable in our audio cable, and that's the shared ground. The white cable goes to the right side, which is going to be this yellow cord here. And the red cable goes to the left, which is the orange. The black connection here we do not use, and is for the microphone input. So now we have all of our inputs. We have our signal input from our audio cable, and we have our power input from our battery pack going into this board. And so now it just has to go out to the speaker. So we're going to use these alligator clips, which can clip onto the exposed wire on our magnet coil. Since we're going to be attaching to one speaker, we only need to pick one of the left or right side. So I'm going to pick this left side here. The output of the board is divided into 2 pairs. I'm going to put one alligator clip on one of the wires and the other on the other. Doesn't matter which is which. So now I could attach these to my speaker, but before I make any final connections, I want to take a bunch of pieces of electrical tape and wrap around each of these connections pretty loosely, prevent the metal parts from touching each other. Putting this electrical tape on here is, we're not trying to hold it in really snug or anything. All we are doing is trying to make sure that the metal parts on one of our connections can't touch the metal parts on another, because we don't want to create a short circuit or mess up the signal in any way. And there we go. So now I have these 2 connections, and I can clip them onto my speaker. My speaker's voice coil has 2 wires coming off, and taking care to clip the ends of the alligator clip to the exposed copper inside of the enamel insulation that I sanded off. So turn on the thing, and I'm gonna hit play. And there we go. Sounds pretty good. So now that we know everything works, we can just use this double-sided tape to secure our board and our battery holder on this base for safekeeping. And you can feel it vibrate, and you can play around with different levels of height, and you can get different sounds, and there's a lot that you can experiment with and redesign to make a better speaker, or a speaker that has different audio properties, and I hope you do.
That's super cool. If you want to build one yourself, you can find written instructions and how to find the parts we used at partsandcrafts.org/makeit. Thanks to Will, and thanks to everyone who backed our Kickstarter, especially Andre Green and Joy and Nancy. If you'd like to support us bringing projects like this to you, you can support us on Patreon. Links are below. Thank you.